everyone. Welcome to the next module on electronic system for cancer diagnosis. Today, let us see how to drive fluids in microchannels. Like I've already mentioned previously, when we are fabricating microfluidic chip or a biochip, we have channels who have cross section, the channel width is as small as 100 micron in length. So, how do we drive fluids in them, and why should you even drive fluids into a channel which is that small? So, as I've already mentioned, these biochip, also called as a microfluidic chip, or it is even termed as lab on a chip, they mimic the biological environment. They have multiple channels in them in order to replicate the biology, the physiology of the organ functionality. So, how do we control fluids in microchannels? Microfluidic flow control is one of the critical technology which has been widely used because of the need for precise control of fluids through these microchannels, which are very low in quantity. The liquid sample what you take to flow through the channels are very minimal, which flows through your biochip. Let us say you, if you want to, in practice, what would be how do you quantify the amount, the channel dimensions, and how much is the fluid that flows through these channels? Let's quantify what is the amount of fluid which actually flows through these channels, which we claim to be, of millimeter or micrometer length scale. So, it is, say you have 1 centimeter cube, how much of the fluid actually goes in 1 centimeter cube? 1 centimeter cube is like you have a 15 centimeter scale, and then you know how much is 1 centimeter, and then 1 centimeter cube, and when you put some liquid, how much of it goes into this cube? So, it is 1 milliliter fluid, which completely, when you do the volumetric conversion, it is 1 milliliter fluid into this 1 centimeter cube. So, now that you know it is 1 milliliter fluid, we are talking in terms of microliters of fluid going into these channels. So, now you get the point. There is very minimal amount of fluid flow which goes through these channels, and how can you precisely control their flow is very critical while we do analysis and while we work with these kind of biochip. So, when I mentioned about lab on a chip, so what is lab on a chip? It is nothing but a chip which integrates the several laboratory requirements into one single chip. The multiple functionality has been integrated on just one chip. So, that is when you call lab on a chip. You analyze, when we say mimicking the entire environment. So, multiple the multiple parts of your environment gets integrated on one single chip. So, on a similar basis, you even talk about organ on a chip. This is an entire body, we have multiple organs. So, how could you actually mimic an organ on a chip? So, the functionality of an organ can be mimicked by including the various physiological, biological, chemical properties by having multiple channels, and then you could actually integrate all of them into a chip. More of this can be studied. There are vast research which talks about lab on a chip, and you could check more of this stuff online. So, now that we know what is lab on a chip and organ on a chip, so you understand that we are driving liquids through these microchannels. So, the liquid driving mechanism becomes very important to us. So, how do you drive liquid? I am sure you have all heard of blood being pumped to various parts of the body. So, when you are talking about pumping, pump mechanism is nothing but a driving force to push the fluids, it could be liquid or gas, to push fluids across the channel. So, in our case, we have these channels and we have fluids which has to be flown through these. That can be attained using micro pump, the pumping mechanism. So that currently we have very well known the driving horses of pumping mechanism are in microfluidic devices or biochips. Mostly used are the syringe pumps and the peristaltic pumps. But today we would be studying more about peristaltic pumps and how it is used in driving fluids through your device, that is the driving fluids through the channels which are engraved in your device. So there are a number of on-chip pumping mechanism. For example, in one of the modules I have spoken about PDMS molding. So you could actually go on and check how a pump could be fabricated using a PDMS device. So, so it's an on-chip pump where the entire pumping mechanism will be taken care with your the design of your elastomer. So more on this can be studied. So you can go ahead and look online how a micro pump can be fabricated using PDMS. So most important requirements for us while we have these micro channel, if we want to precisely control fluid flowing through micro channels, are we require long term stability, repeatability, and we should have fine control over them. So all of this could be achieved using peristaltic pumps. So there are two variations in peristaltic pump. One is the tube pump, the other one is the hose. The hose is mostly used with, they are mostly designed for high pressure pumps. The peristaltic pump what we would be using, they are designed for low pressure operation. So the peristaltic pump has rollers on them, and then there are reinforced tubes which you could actually see, and we will show you, we will give you a demonstration on how are these pumps constructed and how do they work. So they employ rollers which squeeze through the tubes, and that's how the fluid could flow, and you could actually get a fine control over the fluid flow, the rate at which they flow, and the volume of fluid which goes into your device could be controlled. So as you increase, so the number of rollers could range from 2, it could go on to 2 rollers say 180-degree apart, or it could go on to 8 or even 12 rollers. Let us see how many rollers we have in our device which we would be demonstrating. And when what happens when you increase the number of rollers, it is the pulse frequency, the amount of fluid that is being pumped is what changes. So let's get a hands-on the peristaltic pump, which could be used to pump fluid through multiple channels. So like I spoke about the peristaltic pump, this one in my hand is one such pump. This could flow around 90 ml of fluid. Let me show you part by part. So this forms the motor part of the pump, which is the driving force, and here is the casing. This is the tubing through which the fluid flows in and then comes out. Let's say I remove the casing. If you could see this, this is where the motor drives in. As it rotates, there are 3 rollers in this case. Like I mentioned, there could be 2 which are 180-degree apart, and in this one there are 3 rollers. This is 1, 2 and 3. So these rollers push, they compress the outer surface of this pump, of this tube. So here is the tube. As you could see, it's a relatively larger diameter than what we use for our biochip or microfluidic devices. This cannot be used, but this is just for a demonstration how a peristaltic pump looks like and what goes into the pump. This is the tube through which fluid flows, and while your motor drives, each of these roller would compress the pump. It would compress it, and then there is this compression, there is this pulsation, and as it releases, you see there is an increase in volume, and then the fluid tends to move forward. Let me put it back. So this was the tubing, and then goes the 3 rollers. And then here is the outer casing. So this forms your peristaltic pump. Now let us see what kind of pump is used in microfluidic devices or a biochip, where you mimic the biological environment, flow different chemicals, or you could flow like you might flow a drug, test the susceptibility of a particular kind of cells, or test different kind, you could load in cancer cells and test how the drug works on each of this. So let's look at how the peristaltic pump can be used in case of flowing flowing fluid through microchannels. Like we said, there were 2 variations of peristaltic pump, which is the hose pump, which operate with higher operating pressures, and the one what we have is the peristaltic pump, as you can see. So there are rollers inside. Let's see how the peristaltic pump functions. We'll look into the different parts of the pump and see how we could operate them. So the peristaltic pumps what we have here is also called the roller pump, because you can see there could be rollers which are inside, which would put force on your tube, and then the driving mechanism happens. So let's see how the tube has been placed inside. So as you can see here, there are 4 cassettes, 1, 2, 3 and 4. So let's even before we turn on, let us have a look as to how the tubings are placed inside each of these cassettes. We have Suman who would be helping us. So this is one cassette in his hand. You could see the tubing. These are the silicon tubings. And each of these cassettes will have the tubing which would be enforced into the channels. The one in his hand is the channel through which the fluid flows. Now let us see, can you point out to the rollers? So as Suman is pointing out, we have pointing out to the rollers. So there are 6 rollers which triggers the entire pumping mechanism. So it pumps the fluid through these silicon tubes. Let's look on to the diameter. As you can see, the silicon tube, it is 1 mm outer diameter. However, the inner diameter is very small. it is around 0.12 millimeter, which is very small. This is like a pinhole, and then the fluid flows through these 0.12 mm channel, inner diameter channel. So this tube is tensioned between the tubing bed and the rotor. So this is the rotor, this is the tubing bed, and then we have the rotor which actually drives this. The rotor is this way, and the rotor drives, and then this forms the tubing bed. Now, each of these rollers will compress the fluid. As each of these rollers move, they form a compressing action on the tube. The tube will be squeezed continuously through the roller and displace the liquid in the direction in which the roller head is moving. Say this roller head moves in this direction, clockwise direction, so your fluid will be displaced in this direction, say clockwise direction. It also depends on which direction your motor is rotating. And once you say this is the tube, so let us say we put the tube into the cassette and then place it on the rollers. So as it goes into the casing, as you can see, the tube which rests on these rollers, and then between the two rollers there is a gap, and as the roller resumes, the part of the tube which is behind the roller, this faces the compression force, the one which is on the roller, and the one which comes between the two rollers, as it moves towards face is compressed, and then it resumes the shape as it goes away from the roller. So as it moves from this point to this point, it relaxes, it resumes its original shape, comes back to the original diameter, and the compression is on the roller point. So that this creates a vacuum and suctions the liquid, and then the entire process repeats. So this is more like a positive displacement pump. So it pumps the fluid, it pumps the fluid out in the direction in which the roller rotates. Now you can see these, they do not have valve or seal. So this is a very inexpensive pump, and it permits easy flow of solids and viscous media. So let us see how each of these functions. So as we can see, there is a digital display for us, a user interface, and let us see how to operate this pump. So say we turn on the pump. So now we know that there are 4 cassettes, 1, 2, 3 and 4 here, with 4 channels on one side. They are parallel channels. As you can see the digital display, the first is the home, and then the second talks about the configuration of the cassette. It tells how much microliter and the RPM in which it is running. So this is telling, say the symbol what is on the left side is rotating the clockwise. So the first cassette would rotate in clockwise direction, and what is the amount of volume of fluid it draws? It is 100 microliter per second. So 100 microliter per second fluid will be drawn through this tubing. This is the configuration in the first cassette, which is this one. So what are the other options available? And then we have the settings, and this is a settings option, and then now as you can see, he is moved to the second cassette. So that is running at 4 microliter per minute. And at what direction? You could see it is running in the clockwise direction. And we will also show you how you could change the RPM, the rotations per minute, and you could even control the amount of fluid which flows and even the time. So let's say this is my second cassette, and now currently there's 4 microliter per minute. Say I want to, and this is running at 100 RPM. Say I'd like to change the RPM. Now it is at 100 RPM, and then I'll reduce. So like I showed, you could change the rotation. Now it is rotating at anti-clockwise direction. And now from 100 RPM, say I'll reduce it to 50 RPM, 50 revolutions per minute, and the direction is in the anti-clockwise direction. So let us see what is the fourth channel. So the fourth is set at 100 RPM and it is set at clockwise direction. Now let us run and see how the rollers rotate. So as you can see, channel 3, the cassette 3 is rotating in the anti-clockwise and the fourth one in the clockwise direction, and the relative change in speed can also be observed. As you could observe the variations, now let us see what are the other configurations we can do. So let us stop and then do the other configurations. Now as you can see, the cassette 4, now we are in volume. You can even change. So let's say we do the volume per time settings. So let's say we will drive around 2 microliter fluid. So we set it to around 2 microliter for 2 microliter, say for 5 seconds, because the time is, 2 microliter is very small amount of fluid. So let's say we increase the time to around 5 seconds. Okay. Now let us see how is this is the fourth cassette configuration, which is running at 2 microliters per 5 seconds. So say we've taken a petri dish with water, and let's see how the fluid flows. Now since it is the clockwise direction, we have some amount of fluid in the petri dish here, and this is the fourth one. So let's fix the fourth cassette. And also let's fix the third cassette. So this entire pumping mechanism, the compression and the decompressing of the tubing, it is to force the fluid to flow from one direction to the other. As you can see, this working is very much similar to how our body pumps blood, nutrition and oxygen, and this is why we are using this mechanism when we are mimicking the entire bioenvironment, the physiology, the chemistry and the biology onto our biochip, and hence using these pumping mechanism becomes very important, and controlling the amount of fluid which flows through them becomes vital for the accurate functioning of our device. So let's say in cassette 4 we are driving 40 microliters of fluid, and let's set the time to around a minute, say 60 seconds. So we flow 50 microliters per minute, so that it becomes easy for us to visually see how the fluid flows.
This is volume per time, this is your volume, this is your time. If this is 28 seconds, that means in 28 seconds it will flow only this much. Better
in
to
that
make it
time.
10 seconds or even 5 seconds. 5 seconds 50 microliter, then within 10 seconds you will get something here. That is the thing I am thinking.
I think that's too high. You can actually put only 20 microliter for say 5 seconds.
20 microliter 5 seconds.
He put 4 microliter in 3 seconds.
Okay, what is the flow rate?
This thing is not visible. The water is also not visible.
Okay. Sure. Okay. Oh, we can change the RPM then.
Change the channel to 3, okay. Start. Let's see, now we are in cassette 3, clockwise direction, and the volume is set at 5 microliter, which will flow for 10 seconds. 5 microliter of fluid flows for 10 seconds. So, we observe where is the source, and then we have the sink. So, we have taken some DI water, and let us see, in 10 seconds 5 microliter of fluid should be flown from the source into the sink in the clockwise direction. Let us see the other setting. As you can see, there is droplets. Let us check what is the setting in the 4th cassette. So, this is 20 microliters. So, this is a higher volume. 20 microliter of fluid should flow across the source to the sink in 12 seconds. The one in Suman's hand he is holding the 4th channel, and then the other one is the 3rd channel. So, let us see, 12 seconds there should be 20 microliter of fluid which has flown across the 4th channel. So, now that you have seen, we have done the setting. So, in the 3rd cassette we will have some 5 microliter of fluid, and the 4th one is 20 microliter fluid. As you can clearly observe the volume of fluid which is coming out of the channel. Here, as you can see, there is this 4th channel with a higher volume. And the time what we have set is very small, like we have just set it for 5 seconds and 12 seconds, which is very small, but you could set the timing and you could relatively get your hands on the device. So, now that you have got the idea about the functioning of the peristaltic pump, how you can change the volume, you can change the time, you could change the direction of rotation, and there is another feature, you could actually flow the fluid, pause it for some time and then again continue. So, we are on the 4th cassette, and you could change, now we have set the volume and time. So, this is at the volume setting. So, let us see if we could change. So, this is the time and this is volume plus pause. So, when you get into this option, you could control the rate at which it is rotating, you could control the amount of volume, you could pause it. So there is 20 microliter, you could, every time it flows through the time, so there is a pause of 2 seconds, and then you can set the number of cycles. So, like we said, it repeats, the flow repeats. So, you could set the repetition rate. So, this is your cycle which can be set. So, these are the features through which you can work on and then accurately control, precisely control the amount of fluid flow through multiple channels across your device. So, this was the hands-on experience on the peristaltic pump. That is it for today. Thank you.